So today we are going to learn some differentiation formulas. If you remember in the last few sections, we defined the derivative of the function as the limit h approaches to 0, f of x plus h minus f of x divided by h, right? So whenever I had to find a derivative, I had to go through the whole process by plugging in the function x plus h, simplifying it, solving it, and then at the end finding the limit. So that method of derivatives is how the derivatives come using the definition, right? But in general, when we do the derivatives, we have specific formulas which we use to apply and find the derivatives directly without always doing this, right? So today we are going to learn some of these formulas in our sections. So I say it's a good idea as we learn the formulas, you keep building a list of your own formulas and you practice more questions, right? So let's go over the first formulas. I'm not going to go much into the details of the proof for the sake because this course is more for the people who are not going to be majoring in math later on. I'm not going into the details of the proofs theory, but we will note down the formulas. The first one is the constant rule. The constant rule says if you are trying to differentiate a constant, it will be 0. You understand that, right? So derivative is rate of change of a function. If the function is a constant function, it's not changing. So that means change is 0. So the derivative of any constant anytime will always be 0. First formula, derivative of the constant is 0. The next one you need to learn here is if n is a positive integer, then derivative of x the power n. X is a variable, n is the constant positive integer. Then its derivative is n comes down times x the power n is reduced by 1. This is called power rule. So let's write it one more time to remind you. Derivative of x the power n, power comes down, times x the power 1 less x the power n minus 1. Okay. Again, not going much into the proof of this, but you will have to remember the formula. It's called power rule. Okay. Let's use these power rules here. For example, let's say f of x is x. If f of x is x, then power is 1, right? So let's say f of x is x power 1. Using the power rule, the derivative will be 1 comes down, x the power 1 minus 1, 1 times x the power 0, that will be 1. Anything's power is 0 is 1. So in general, whenever you're just differentiating x, right, you're gonna have to remember this as a formula too. You can add this as your formula list too. Derivative of x is always just 1. Let's practice some more examples here. If f of x is x the power 10, then the derivative will be power comes down times x the power 10 minus 1. So 10 times x the power 9. Okay. Let's look at the next one. If f of x is square root of x cube, right? First of all, square root means the power is half. Power of power, powers multiply. Power of powers, powers multiply. Okay. So the derivative will be power comes down, power 1 less, 3 by 2 minus 1, 3 by 2, x, 3 by 2 minus 1 is half. So 3 by 2 root x would be your answer. Okay. Sometimes it's, what about the last one here? Number 4. F of x is 1 by x to the power 4. It's a reciprocal of x to the power 4, so that basically can be written as x to the power -4. So when you find the derivative of this, -4 comes front, x -4 minus 1. -4 x -4 minus 1 is -5. That means -4 x to the power -5 can go down to make the power positive. That's why the derivative of this is -4 by x to the power 5. Okay, so this is a little practice. Let's do one more. Let's say if we have f of x as root x. What does root x means? X to the power half. So if you need to find f prime of x, power comes down. Power 1 less. Power is 1 by 2. Half minus 1 is -half. That can go in the denominator and it'll become x to the power half. And x to the power half can be written as root x. So basically, what I'm trying to say, if f of x is this function, then f prime x is 1 by 2 root x. I want you to write this in your formula sheet too. Okay, so some practice. I want you guys to do more practice problems for the formulas to use how to practice them. Okay. Now, the next one is the constant multiplier rule. Meaning, if we have a function f of x and it's being multiplied by a constant c and we want to differentiate it, c, the constant can come out of the derivative easily. So it will be c times whatever the derivative of f is. So derivative of c times f of x, c will just come out of the derivative. You will simply differentiate the function. That's called constant multiple rule. Next we have if we have two functions f and g, both are differentiable. If you want to find the derivative of their sum, you just separately differentiate each of them. And same is for the difference. If we have two functions, both are differentiable, you can just separately differentiate each of them and put a negative in front, right? So these formulas are really interesting and easy to use. Let's see. For example, we have to find the derivative. It says first 3. I'm going to just find the derivative of this function. F prime x. Now this is sum of and differences of different functions, okay? So f prime x will be the derivative of the first minus the derivative of the second term plus the derivative of 6x plus the derivative of pi. Okay, fix my pi here. Now, let's look at the first one here. 4 is just a constant multiplier, so 4 can come out, and inside will be derivative of x to the power 5 minus 3 is just a constant multiplier, so 3 can come out, derivative of x square, plus 6 is just a constant multiplier, so 6 can come out, the derivative of x, plus pi is just a constant always, right? Pi is a fixed number, so derivative of pi will be just 0. Do you guys understand that? Okay. 4. Now x to the power 5, we can do derivative using the power rule. Okay, power comes down, power 1 less, 5 minus 1 minus 3 times the derivative of x square. 2 comes down, power 2 minus 1 plus derivative of x. We just learned derivative of x is just 1. Let's write all that together. 4 times 5, 20 x to the power 4 minus 6 x to the power 1. We don't really need to write it, plus 6. So derivative of the given function would be 20x4 minus 6x plus 6, using all the formulas which we just learned.